Hello dear students, today let me continue from nitration of pyridine. Okay. Now pyridine undergoes nitration in the presence of sulfuric acid. You can see here sulfuric acid heated to 573 Kelvin. Okay. And the reactant, other reactant is potassium nitrate. So pyridine reacts with potassium nitrate in the presence of sulfuric acid heated to 573 Kelvin. 3-nitropyridine is obtained. Alright. Next is sulfonation. Pyridine on heating with sulfuric acid, temperature is 503 Kelvin. In the presence of mercury sulfate catalyst, we get 3-pyridine sulfonic acid. So in the third place, sulfonic acid group introduced into the ring. Okay. So 3-pyridine sulfonic acid is obtained. Alright. Now next is halogenation. Pyridine reacts with bromine in the presence of charcoal, temperature is 573 Kelvin, to give a mixture of 3-bromopyridine and 3,5-dibromopyridine. Okay. Next is Friedel-Crafts reaction. Pyridine does not undergo Friedel-Crafts reaction because of the presence of Lewis acid, okay, which is used as a catalyst in the reaction. Okay, it forms a complex. Now how to write the equation? Pyridine reacts with aluminum chloride, okay, to give one an complex pyridine aluminum complex. This is the complex formed. See, lone pair of electrons of nitrogen forms a here bond with aluminum, so that this becomes positively charged, nitrogen becomes positively charged, aluminum will bond it to one chlorine, okay, chlorine in the negative ion, in the form of negative ion. So pyridine aluminum chloride complex is formed. Next is nucleophilic substitution. Pyridine undergoes a nucleophilic substitution at the second position or fourth position. The electron deficient nature of 2 and 4 positions of pyridine is responsible for its greater reactivity towards nucleophilic reagents. Okay. Now first one is attack at position 2. Okay. Position 2, nucleophile means nucleus attractor, therefore it should be negatively charged. So Nu minus, okay, it is negatively charged. So negatively charged nucleophile attacks positive center. So which is the positive center now? Second place, okay, because this nitrogen will pull the electrons towards itself, okay, and becomes negatively charged. You can see here. So that second place becomes positively charged, so that nucleophile easily attacks towards second position. Okay. So this exists in resonance with this form, okay, by the shifting of electrons, okay, because it is the pi electrons are delocalized, okay. So another resonance form is obtained with the elimination of hydrogen negative ion, okay, negative ion. So H minus is eliminated to form 2 or second substituted product, okay. Similarly, fourth attack you should have fourth place positively charged, okay. Fourth place positive charge means this pi electron gets shifted towards the third place, okay. Here negative or pi electron gets shifted here, okay. So negative charge is formed here, third place, so that positive place is fourth place, okay. Therefore nucleophile attacks at fourth place. So here also there are 3 resonance structures are formed, okay, which are more stable. So this is also more stable, these resonance structures also more stable. So once again elimination of H minus to give on 4 substituted products or fourth substitution product, okay. Similarly attack at 3 also we get 3 resonance structures, okay, but these are less stable compared to second and fourth attack, okay. Now Chichi-Babin reaction, okay, Chichi-Babin reaction. Now what is Chichi-Babin reaction? Pyridine reacts with sodamide. What is the formula of sodamide? NaNH2, okay. Sodium is positive charge, NH2 is negatively charged. In the presence of ammonia heated, okay, liquid ammonia heated, we get one the 2-aminopyridine. We get 2-aminopyridine. This is the product formed. Okay. Next is alkylation. So pyridine reacts with normal butane lithium heated to 373 Kelvin. We get 2 normal butyl pyridine. Okay. Normal butyl pyridine with the formation of other product as lithium hydride. Next is arylation. Arylation is nothing but phenyl lithium is reacting with pyridine. Okay, same temperature. We get 2 normal phenyl pyridine. Okay. Now next is hydroxylation. Okay. In hydroxylation, pyridine reacts to sodium hydroxide heated to temperature 593 Kelvin. 2 hydroxypyridine and 2 pyridone is obtained. Okay. Next is oxidation. Oxidation. Pyridine undergoes oxidation with per acids like per benzoic acid. So this is should be C6H5 CO2H. Okay, CO2 and O, CO and CO2H. Okay, this is not acetic acid. There is a mistake over here. It should be C6H5 CO2OH. Okay, or CO and then okay O2H. Okay, so CO2OH or CO3H. Okay, so that is per benzoic acid. We get one pyridine N oxide. Pyridine N oxide is obtained. So nitrogen is a positive charge, oxygen is slightly negatively charged. Next is reduction. Reduction, okay, in the presence of nickel, that means nothing but hydrogenation in the presence of nickel heated to 473 Kelvin, piperidine is obtained. Okay, how do you get piperidine? All the 5 places we get additional hydrogen. Okay, so you have one CH2, okay, all places, and here nitrogen, this nitrogen attacks one hydrogen. Okay, so you get one piperidine. All right. Next, formation of quaternary salt. So pyridine reacts with methyl bromide, okay, to give one N-methyl pyridinium bromide. N-methyl pyridinium bromide is formed, N plus and CH3 Br minus. Okay. Now next is comparison of basicity of pyridine, piperidine and pyrrole. Okay. The lone pair of electrons present in sp2 hybrid orbital of nitrogen in pyridine is not involved in the formation of aromatic sextet. Okay. It is readily available for the formation of new NH bond with the proton. Hence, pyridine is basic in nature. The lone pair of electrons in pyrrole is in the p orbital and forms a part of delocalized pi molecular orbital. It is not available for the formation of new NH bond with proton. Hence, pyrrole is less basic than pyridine. Okay. Now, what happens in the case of piperidine? Piperidine has got a lone pair of electrons. Okay. Still more available because it is sp3 hybrid. sp3 hybrid orbitals are okay present in piperidine. So the lone pair of electrons are still more available. Hence, piperidine is more basic than pyridine. Okay, than pyridine. So you can see here, okay, lone pair of electrons present in sp3 hybrid orbital of piperidine. So electrons not involved in the formation of aromatic sextet. Electrons loosely held because of large size of the orbital, available for the formation of new NH bond with proton. So piperidine basic in nature. This is pyridine, lone pair of electrons, okay, sp2 orbital. This is pyrrole. Okay. Next, let us see pyrazole. What is the IUPAC name of pyrazole? 1,2-diazole. Okay. So this nitrogen is pyrrole type nitrogen, whereas this nitrogen is pyridine type nitrogen. So it has got 2 types of nitrogens. Okay. Pyridine type nitrogen and pyrrole type nitrogen. Now synthesis. How it is synthesized from acetylene? By passing acetylene into a cold ethereal solution of diazomethane. Okay. So acetylene reacts with diazomethane, okay, to give an addition product. Okay, this is the addition product formed. Okay, by the shifting of pi electrons. Okay, you can see here. So finally we get what? Pyrazole. Next method is from acrolein and hydrazine. Okay, this is the formula of acrolein, CH2 double bond CH2O. Okay, hydrazine formula is NH2NH2. Okay, only thing is it is written in this way, so that you can easily identify the ring, pentagon ring. All right. So elimination of water molecule taking place, elimination of hydrogen molecule taking place to give what? Pyrazole. Okay, pyrazole is nothing but pyrrole plus azole. Okay. So you have the molecular structure. Next, reactions of pyrazole, basic and acidic character. Pyrazole is a stronger base than pyrrole because the lone pair of electrons on pyridine type nitrogen is not involved in the formation of aromatic sextet. Okay. But however, the direct linking of two electronegative nitrogen atoms decreases the basicity. Hence, pyrazole is a weaker base than oxazole and thiazole. Alright. Pyrazole forms salts with inorganic acids. It is also a weak acid due to pyrrole type nitrogen. Since it is acidic in nature, it reacts with the alkalis to give what? Salts. Hence, it is an amphoteric compound. Okay. So, since it is basic in nature, it will react with acids, okay, to form salt, which is the salt formed here with Cl, pyrazolium chloride. You can see here N plus Cl minus. Okay. Then, since it is acidic in nature, it will combine with base. You can see here pyrazole combines with base potassium hydroxide to give potassium salt, that is potassiopyrazole. Okay. Now, next is electrophilic substitution. Pyrazole is less reactive than fluorine, pyrrole and thiophene due to the presence of electronegative nitrogen. Electrophilic substitution takes place only with strong electrophiles at fourth position. Okay, strong electrophiles at fourth position. First one is nitration. So, pyrazole reacts with nitric acid and sulfuric acid. Okay. This acts as catalyst to give 4-nitropyrazole. 4-nitropyrazole is formed. Next is sulfonation. Pyrazole reacts with sulfuric acid in the presence of oleum 523 Kelvin. Pyrazole 4-sulfonic acid is formed. Next is halogenation. Pyrazole reacts with chlorine to give 4-chloropyrazole. You can see here fourth place chlorine. Okay. Next is chloromercuration. Now in chloromercuration, pyrazole reacts with mercury chloride. Okay, giving 4-chloromercurypyrazole. This is the equation. Okay. So R mark is missing over here. So mercury chloride, it gives 4-chloromercurypyrazole. Next is alkylation. Pyrazole reacts with alkyl halide, example is methyl iodide, okay, to give N-methylpyrazole. So N-methylpyrazole is obtained. Okay. Now next is reduction with the sodium. Okay, sodium in the presence of ethyl alcohol. Okay, ethyl alcohol. So pyrazole undergoes reduction in the presence of sodium and ethyl alcohol to give 2-pyrazolene. Okay, 2-pyrazolene. Next with the platinum. So reduction is carried out in the presence of platinum, heated platinum. So pyrazole gives pyrazolidine. Okay, all the here 4 corners will be occupied by hydrogen, substituted by hydrogen. So you get pyrazolidine. So pyrazole is stable towards oxidizing agents. Okay. So I will stop at this stage. Please go through all the slides. Okay. So thank you.